Mrs. Reason again, here to give you a little lesson on adding and subtracting rational expressions. Our first example will look at adding and subtracting fractions, or rational expressions, with the same denominator. Step 1 is to add or subtract the numerators. Step 2 is to write the result over the original denominator. You can see in our example that my denominators are the same, 5x squared. When your denominators are the same, all you have to do is add your numerators together and put them over that original denominator. Let's look at a couple more examples. Example A, 7 over 4x plus 3 over 4x. The denominators again are the same, so when I add 7 plus 3 I get 10 and put it over the original denominator of 4x. Letter B is subtraction. My denominators again are the same. Subtract your numerator. There's nothing else you can do but write it like that and write it over the original denominator. You try the next 4 guided practice. Pause the video and come back for the answer when you're done. Here are the answers. If you notice, some of them needed to be reduced. Number 1, we needed to reduce our numbers. Number 2, this 3 and that 3 could cancel, simplifying to that result. Number 4, there was nothing else we could do. And number 5, after we added the numerators, we could have factored that numerator, and then we would see that we have 2 factors that would cancel. Our final result was 2. Let's move on to looking at subtracting or adding fractions, or rational expressions as we call them, when the denominators are not the same. To add or subtract rational expressions with unlike denominators, your first job is to factor everything. And from factoring everything, you're going to find a common denominator. The next step would be to rewrite both fractions so that you had a common denominator. And finally, add or subtract the numerators and write that result over the common denominator. Alright, let's look at example 3. I have the problem 7 over 9x squared, and to that we are adding x over 3x squared plus 3x. Your first job is to factor the denominators of both, because this second denominator here can be factored. Now this is where it can get tricky. You need to start to ask yourself some questions. The first one is, what factors are missing from this denominator that the other fraction has in its denominator? Well, I have a 9 over here, which is a multiple of 3, so we can consider that covered. I have an x squared over here, and that's a multiple of x, so I'm good there. The one factor that's missing in the first fraction is this one right here, that binomial x plus 1. Because it's missing in the first fraction, I'm going to need it in order to create my common denominator. As with most things in math, you can't just multiply by x plus 1. I need to multiply it by the fraction x plus 1 over x plus 1. This is really just the number 1, so I am not fundamentally changing this first fraction. I'm just making it look different. This will lead me to my common denominator, but I'm not done because I need to find out if I'm missing any of the factors in this denominator that were contained in the other one. I am missing a factor of 3 in this denominator. This had a 9 and that had a 3. So I'm going to multiply the right side by 3 over 3. I now will have a 9. Looking at the x's, I have one x here, but I have 2 there, which means I'm missing one. So I need to multiply as well by an x over an x. Now look at your denominators. They have a common multiple now. I have 9x squared and x plus 1. Over here, I will have 9 and x squared and x plus 1. That's the hardest part of these problems. Now we just need to clean up our numerators. My first job is going to be to multiply the numerator. When I take x plus 1 times that 7, it's going to become a distribution problem. And you will end up with 7x plus 1 when you multiply that. Over on the right side, I need to multiply this 3x times another x. That's just 3x squared. You can write this all over the common denominator, which is 9x squared x plus 1. Now your only job left is to add together the numerators, and they're kind of added already, but let's put it in standard form, meaning our degrees need to be descending. So I'll just rewrite it as 3x squared plus 7x plus 1. You've now done what you were asked to do, and that was to add these two fractions together. We did that, and therefore we're done. Here's another example where our denominators aren't common yet, but it's subtraction instead, which we need to be a little bit careful about. We'll start off with our step 1, which is to factor our denominators if they can be factored. My first fraction's denominator can be factored because it has a greatest common factor of 2. So let's write that. I'm going to factor out the 2, leaving us with x minus 1. In the numerator, you could factor out a negative 1 if you wanted to. It won't matter, but I'm just going to leave it for now because I'm all worried about getting my common denominator. Factoring the denominator will lead to two binomials. I will have x minus 3 and x minus 1. And now we need to look and decide what we need to have a common denominator. Over here I have a 2, but I don't have one over here, so I'm going to need one. I'm going to multiply this side by 2 over 2. Next, I have an x plus 1 here, and I already have one there, so I'm good with the x plus 1s. But this denominator is missing a factor of x minus 3. So I will need to multiply top and bottom by x minus 3. Now take a look at our denominators to make sure that they are in fact common. I have a factor of 2 over here and over there, a factor of x minus 3 in both of them now, and an x minus 1 in both of them. So now we need to clean up our numerators, and then we can subtract these things, and we need to be careful of this minus sign. Starting off with this fraction's numerator, I'm going to need to FOIL, because these are two binomials being multiplied together. So that will get me x squared minus 3x plus 2x minus 6. And I'm going to make a big line for my new denominator. After that, I'm going to need to multiply this 2 times everything there. I'm going to write a big minus sign there because this is subtraction. But I'm going to put parentheses because remember that subtraction is going to change everything's sign after it. So multiplying this 2 times that negative 2x is going to give me a negative 4x. And then 2 times that negative 1 will give me a negative 2. And I'll just write down our common denominator then, which is going to be 2 x minus 1 and x minus 3. And now I need to clean up my denominator even more before I can subtract them. In my numerator, after I distribute that negative sign, I'm going to get x squared minus 3x plus 2x minus 6, and then I'm going to distribute this negative sign to get plus 4x plus 2. And then before I rewrite my denominator, I am going to simplify that numerator. X squared cannot be combined with anything. My negative 3x plus 2x is a negative 1x, and that negative 1x plus 4x is going to be a positive 3x. Then I have minus 6 plus 2, which gives me a negative 4, or minus 4. And then take that answer and write it over, again, your common denominator. Now we've done what they've asked and we subtracted these fractions. The problem is it's not a simplified fraction. You can factor that numerator into x plus 4 and x minus 1. And then you should notice that your numerator and denominator have a common factor, which you can cancel out. So your final answer to this problem will be x plus 4 over 2x minus 3. Here are some guided practice problems. Try 7 and 8 first. Pause the video and come back and check 7 and 8 to make sure they're right before we get to the tougher ones, 9 and 10. Pause now. Here are the answers for 7 and 8. There is nothing else you can do to those to simplify them. Move on to 9 and 10 and come back when you're done. Pause the video. And here are those final answers.